we're doing that demo with Nirali and Michael, and this is on automated modern Gov software factory in Azure.
Hello, everyone. It's great to be back tonight with this group. Thanks, Karina, for having us today. I'm Nirali Shah, a PM on the Azure Global Government team at Microsoft, and I'm here today with Carlo, Brandon, and Michael, engineers from our 2020 Microsoft US Partner Award winner, CloudFit Software. So back at the May Meetup, we gave a demo showcasing DevSecOps on Azure for Gov workloads, so this slide may look familiar. Particularly, we looked at using OpenShift and Zero Trust in an Azure environment, but that was only part one. So tonight, we're giving you part two. We'll be continuing our conversation by looking at not just a piece of, but the actual full software factory for Gov workloads that we developed for Azure. And we'll see how we can set up a complete dev test prod environment, a full stack of modern open source and other developer tools quickly and efficiently. We'll see how that software factory builds upon government-focused DevSecOps principles. So let's recap those principles from the last time. With our software factory, we're aiming to first accelerate speed of deployment and delivery by providing you with an automated environment so your developers get to focus on writing code and building and delivering application workloads at speed. And second, we provide an advanced security posture. This is a success part of DevSecOps. And lastly, we're aiming to make compliance easier to monitor and achieve with 24-hour security. So let's show you actually how our solution does achieve these principles and how we built it to work. First, we're going to dive into a high-level architectural overview of our proposed solution for tonight. Awesome. So here we have the full composition of the software factory. In this diagram, you're going to see a lot more tools than just OpenShift from last time. So last time in part one of the demo, we only deployed OpenShift and we ran a workload directly on that OpenShift cluster. This time, we're going to expand our deployment. We're going to deploy our container orchestration platform and then run our entire DevSecOps tool stack on top of that cluster. First, let's talk about why did we choose these specific tools. So our main priority is meeting developers where they are. We've taken the time to listen to several government customers and leaders in this space to really understand business needs around DevSecOps and what tools folks are using to meet those needs day to day. And from that research, we landed on this optimal and core tool set for the typical Gov app developer. But keep in mind that this isn't the only tool set we're working towards enabling on Azure. As we continue to engage in this space, our roadmap is evolving and we're taking into account more tools we're trying to target so we can expand our DevSecOps offerings. So let's go through each category of tools here quickly. Take note at the top of this diagram that this DevSecOps ecosystem, management layer, as we're calling it here, can be deployed on Azure Government for Impact Level 2 to Impact Level 5 workloads, and even on our classified cloud, Azure Secret, or IL6 workloads. We're going to get to that a little bit more later. Now, first up in this management layer stack here, you can see container orchestration. This layer is the part of the ecosystem that deploys and manages Kubernetes nodes. So this time, as I said earlier, instead of OpenShift, we'll be leveraging an Azure Managed Container Orchestration Platform, AKS, or Azure Kubernetes Service. And we'll tell you more about AKS in just a minute. Next, we have logging with the ELK stack. So that's the second yellow arrow. The ELK stack includes Elastic and Fauna using Istio as a service mesh to power the underlying network there. We chose these tools because of high customer interest and the DoD's generally recommended logging architectural framework. And then down below, you'll see some other categories of tools here like security, collaboration, plan, dev, build, and test, and finally monitoring. And you'll likely recognize some familiar tools here like Encore, Jira, and Mattermost that complete our full DevSecOps stack. So how do we get all these tools up and running within a matter of minutes to help you get to coding faster? Let's show you that now. First, we're going to set up AKS or Azure Kubernetes Service, like we mentioned. AKS is our CNCF compliant Kubernetes hosting platform. It comes with features that integrate easily with the broader Azure ecosystem, making your use of Kubernetes on the cloud truly seamless. So this includes features like Azure Dev Spaces for easy debugging, Azure Policy with an OPA gatekeeper integration for compliance and governance, and our new coming soon open service mesh for zero trust traffic control between microservices. So with that in mind on Kubernetes, let's go to the Azure Gov portal to spin up those AKS clusters now. All right. So here we're in the Azure. Our deployments today will be in Azure Gov, which, as I mentioned before, supports IL2 to IL5 workloads. But again, you can also run this on Azure Secret. So let's open up Azure Cloud Shell. For those who don't know, Azure Cloud Shell is an easy to use command line tool that Azure offers right there in the Azure portal. So let's run the following command to spin up our AKS cluster. Cool. So here you can see that first we're creating an AKS cluster to be stored in the resource group named my-rg. We've given our cluster the name demo AKS cluster. We've established 5 nodes on the cluster, and we've enabled monitoring to ensure high observability of all times on the cluster and anything we eventually deploy on. All right, so let's go ahead and run that. For the sake of time, though, we're going to fast forward here to a pre-baked cluster that we've set up for the demo ahead of time. So let's minimize the Cloud Shell and let's click on resource groups under Azure Services right there. And from here, we'll click into demo testing. And then let's click on our demo AKS cluster. So if you remember back to just a few seconds ago on our command, this follows the name we gave the cluster. Here at the top of the screen, you can see that the status of the cluster is succeeded. You can also see that we have 5 nodes, which matches the number in the command we ran earlier. And you can additionally see the Kubernetes version of the cluster is 1.16. So really, with just one single command, we were able to get our secure AKS clusters up and running. Okay, so now we have our baseline clusters successfully deployed. We're going to deploy our logging tools we mentioned earlier on top of them. So let's take a quick look at how this is architecturally going to work. Awesome. So tonight for our logging tools, we're going to be deploying Elastic and Kibana. These are 2 tools that are part of the highly used help stack for research, logging, and analytics purposes in the government space. So for each one of those tools and each one of the rest of the tools on the stack, we're going to go to Iron Bank or Repo 1, which is the DoD's trusted repo for hardened applications, and we would pull down the tools corresponding container images from there. So let's show you where Iron Bank lives really quickly.
And Nirali, there was a question. Do we know when secure containers for Windows to be used on P1? When will that be available?
So that has been submitted to Repo 1, and we are waiting for official confirmation on that.
Great.
I can follow. I'm happy to follow up with questions. Okay, so yeah, here we are on Iron Bank. So here we have Elastic, and here we have Kibana. So for tonight, we pre-downloaded these secure images for Elastic and Kibana to ACR or Azure Container Registry on our Azure Gov subscription. If you want to learn how to pull and use these images from Iron Bank, you can check out our last demo. You can access this code in our open source repo that we've made available to you called the ATO Toolkit. And let's go there now to see that source as well. So there you can see the Iron Bank directory, which has that code. Okay, so now that we've shown you the sources of those 2, let's go back to the Azure Gov portal and Cloud Shell and get into actually deploying all this. All right, so we're going to start an automated script to do that deployment now. And while that takes about 60 seconds to run, I'll tell you a little bit about what's going on behind the scenes. So to deploy these tools, we'll use the EC operator or the Elastic Cloud on Kubernetes operator. We've made this operator installment available as a script in the same ATO toolkit repository we just mentioned, and we pre-cloned it for this demo and loaded it into the Cloud Shell. So using this script, we'll get a much shorter and integrated deployment of Elastic and Kibana on our already running AKS cluster we just set up. So the whole time we're staying within the Azure portal instead of going out again and again to each tool's website to download and install. So here, take a look at what the script is doing. First, we're connecting to our AKS cluster that we set up. Then we're applying the X operator. And then we're showing you to make sure that it's successfully installed. Then we're deploying Elastic and Kibana on top, and we're making sure that those containers come up. And as you can see, the pods do exist, and they're all right there. So now in the next part of our demo, we're going to show you not just these logging tools, but all of our containerized tools in our stack, operational and up and running in a more visualized way. So for the sake of time, we aren't going to take you through the automated install of each tool. We're going to fast forward to the last layer, which is at the bottom, the monitoring layer, and show you a dashboard view with the full software factory setup. And we'll show you how we can achieve high defensibility and observability with this full DevSecOps ecosystem. So without further ado, I'll pass it off to the brilliant Michael Herndon, Chief Transformation Architect at CloudFit, to keep taking you end to end.
Thank you very much, Nirali. So what we're going to take a look at now is actually the CloudFit software scenario enabling dashboard. So with this view, we're going to be able to take a look at the entire software factory environment we just deployed. One thing to establish before we go any further with this, do not think of CloudFit software CFS as a monitoring solution along the same lines as a SolarWinds or Splunk. Instead, CFS tells you if your business and mission scenarios are producing the right outcomes and tells you why that scenario or mission objective is not functional when and if it goes down. This is built on Kibana's automated deployment that Nirali just spoke about. And so here we see visualizations of active containers. That's there in the top left section of the screen. And then also container availability a little further to the right. And then we also see relative health and performance of key components inside of the software factory environment. Here we have Prometheus memory usage as well as Prometheus CPU usage. And then below there you have a trend of these critical performance stats over time. Now, with this, you can see that it's very easy to have a great deal of information available about your software factory environment available to you at any time at a glance. Now, we don't want to start there, though. What we want to do is extend that functionality to specific scenarios and escalation protocols that are built on top of business rules that automate real-time alerts and notifications. Each scenario has different KPIs or key performance indicators. And these will tell you in your leadership when any outcome or mission objective starts to drift away from success. So to demonstrate that a little further, let's focus on the top left here where we have container compliance. So in the background of our automated deployment today, we have Azure policies in effect for governance. And those policies ensure that only the expected hardened containers are deployed in the environment at any given time. So to demonstrate how this compliance business rule can give you real-time notification, what we're going to do now is we're going to inject an incident into this environment. So we're going to inject a non-compliant container into the environment. That will trigger a voice alert to my phone, which I'll share here on the call. And then we'll also remediate that instance.
Container has been detected in your cluster. A new incident has been created for container compliance. You can view the incident on the CFS dashboard.
And so from that, that was the automated message letting us know that a non-compliant container had just entered in to the software factory environment. And as you can see here, the dashboard here has confirmed that voice message. Our container compliance messaging has now become not compliant. And then if you'll notice just to the right there in the container compliance graph, as that updates, you'll see that there is now, instead of a green compliance standard, we're going to start seeing the incident model there as sort of the dreaded red fence across this. And so that is set on a every 30-second update interval. Now, it's important to note again that these types of real-time business rules can be automated and escalated in a variety of ways, whether that be a voice message to the phone, like you guys just heard from my mobile device, could be a text message, email, automated conference bridge, an escalation to an identified knock, or we can even wake up leadership, say, C-suite executives or three-star generals or admirals, however far up the chain you'd like to go. So now that we've injected the incident here, and you can see the red fence populating there, what we're going to do now is our SRE team is going to correct that error on the fly, and we'll see this come clear. And so you see now that the container compliance is back to compliant, and then over to the right, you'll see that our container compliance graph will start trending back up toward green. And there we go. So you may think, or some questions that were often asked is, how can I get CFS? How does it work? Where is it available? CFS can easily be installed on your AKS cluster, just like we did in this demonstration with Elastic and Kibana. It's also available in the bank as a hard container. And again, all of the scenarios and installations are customizable. You can push it down to the tier 1 support layer of any organization or directorate or mission command, and put this type of valuable information there in the hands of the first responders of the organization. Or you can have a VIP white glove different leadership groups, giving them a proactive address and status or sit rep of any mission drift. Now, moving on from this dashboard, in the case that you're trying to develop predictive learning models in conjunction with software, and you want an MLOps software factory, we're going to tell you how you can do that too. This software factory that we've automated stood up this evening can serve as a baseline. All the automation up to this point is establishing DevSecOps functionality. Now you can add on an MLOps piece with a machine learning platform like Kubeflow to extend DevSecOps into your other business needs when trying to build predictive models. So backing up a few steps, MLOps, machine learning operations, is an extension of DevOps and DevSecOps. The DSOP principles of baked-in security, continuous integration, delivery, and deployment are applied to the machine learning process to produce meaningful trend analysis, causation studies, predictive pattern finding. Basically, what all that is that you have faster experimentation, faster deployment of models in production, quality assurance of data, validation of findings for greater and faster ROI, return on investment. So we did mention Kubeflow a moment ago, and today Kubeflow is one of the de facto standards for machine learning. There are others, of course, but Kubeflow is in use for many mission scenarios across the DoD. And so as part of our deployment today, we've also substantiated Kubeflow in the same automated fashion. So here we see the Kubeflow user interface available. You can see that it's online and ready to go. And so now we're going to take a look at the available notebook servers that we have in this substantiation. And we will connect to our current Jupyter notebook. There we go, and there's our MNIST experiment. And so this just shows a hello world proof of concept, letting you know that the Jupyter Notebook is active, that Kubeflow is operational in this MLOps automated deployment. So we have all of your expected functionality here. You have your opportunities to load packages, load, plot, and prepare data. You can also train different models. And of course, load in your predictions or assumptions about data sets. And then based on those, how those predictions and assumptions compare against the evaluated performance, then you can actually generate classification reports, talking about or speaking to accuracy, averages. You can generate confusion matrices, and then you can also have prediction labels or tags to really put meaningful metrics behind your machine learning initiatives. So with that, I hope that you guys are able to see the value today. How this automated deployment can extend to the CloudFit software scenario enablement, and also how machine learning ops can be extended out of DevSecOps.
There's two questions, a couple of questions. One is, what is the start to finish deployment time for the entire stack on average?
Now, you know, I hate to answer that with a cliche, but it really depends. It depends on the number of tools that you include in that, and the deployment time that we have here today, start to finish, that's going to be really less than 30 minutes.
Great. And the second question is, can you address how you tackle issues in a multi-agency federated environment?
So do we have a little more context to that question? That seems like a pretty broad topic. We might need to follow up on and take a deeper dive after this. But
yeah, that's from Anthony Rogers. I don't know if we have more clarification.
If we're talking about okay, I found his question here in the chat. So if we're talking about tackling these issues in a multi-agency federated environment, meaning a multi-tenant or multi-cloud environment there, and also multi-agency in terms of differing business systems versus mission systems, Carl's from that. You know, the approach to that is you can take each one of those as a separate enclave. The tools can be shared as shared services across subscription boundaries inside of Azure. And then also, in terms of best security practices, it's best to deploy across multiple clusters, whether that be AKS or other containerized tooling, so that each enclave has the smallest attack window or threat vector as possible. I hope that helps, and again, happy to follow up later after.
Thanks for fielding those questions, Marina. And I'm about to finish up here. So thanks, Michael. I'm gonna take back the spotlight for a second, and we'll provide our email addresses at the end, so anyone can jump in and ask any questions to us personally. So in review today, to wrap up, today we showed you how you can set up an end-to-end DevSecOps container factory for both software and ML workloads on Azure. So I hope we were able to get across that Microsoft's and CloudFit's development efforts are truly coordinated across the DoD, tracking parity with our platform where we can, and enabling new and innovative landing zones for critical missions, all empowered by Azure. So most importantly here, meeting developers where they are, given our commitment to making open source and third-party tooling installations available and enabled on the Azure platform, instead of trying to reinvent the wheel altogether. We're actively working to make this automated modern software factory available for widespread customer use, either directly in the portal or open source as a quickly searchable and one-click deployable solution. And at scale, we've successfully tested and ensured that this software factory is compatible on all Azure regions, as I mentioned earlier. So stay tuned for this coming soon. We'll try and plug in with Karina's and Vishwas's channel here to make sure that we communicate out. But check out the ATO toolkit for some of the resources and installations we mentioned today to get you started. So please do keep in touch with us on this work in the DevSecOps space, and feel free to reach out to us personally at any time with your questions. Hope you enjoyed your time with us tonight. Thanks for the opportunity.